Hello everyone, this video is for week 10, topics 11, 12, 13, part 1, logarithmic functions. This topic can be found on your modules on pages 143 to 152, examples 1 to 5. For the lesson outline, number 1, review the logarithmic function is the inverse of an exponential function. Represent the logarithmic function through its equation, table of values, and graph. Analyze the basic logarithmic function by identifying its domain, range, intercepts, zeros, and asymptotes, and sketch the graph of logarithmic functions. So to start, let us first review the inverse functions. So find the inverse of f of x is equal to b raised to x. So if you can still remember, we have 3 steps in determining the inverse of a function. The first one is to change f of x to y. So we have y is equal to b raised to x. Then the second one is to interchange the x and y. So you have from y, it will be changed to x, and x will be changed to y. And then we will be solving for y in terms of x. Okay, so we will be expressing this into logarithmic form. So remember, this is the base, the exponent is the answer of your logarithm, and we have x is the argument. Okay, and last one, you have f raised to negative 1, or the inverse of the function x, is equal to the logarithm of x to the base b. Okay, so this is the logarithmic function, which simply means that the inverse of exponential function is a logarithmic function, or it could be the inverse of logarithmic function is an exponential function. So yes, we have from exponential function, and you have your logarithmic function. The inverse of exponential function is a logarithmic function, or the inverse of a logarithmic function is an exponential function. So we have another example. Find the inverse of y is equal to 2 raised to x. So we have y is equal to 2 raised to x, and then interchange the x and y. Next, we will be solving for the value of y in terms of x. So of course, you can only do that if we will be expressing that to logarithmic form. So you have y in terms of x. And the last one, we have the inverse of the function f is equal to the logarithm of x to the base 2. Okay, so the inverse of the given function is a logarithmic function. Now let us discuss example number 1, and we will be sketching the graph of these two functions. Y is equal to 2 raised to x, and y is equal to the logarithm of x to the base 2. Okay, so let us start with the first function. So the first function is an exponential function. So we will start by completing this table of values. So the domain of this exponential function is a set of real numbers. So we will just be using the integral values of x from -4 to +3. So let us evaluate this function. So if your x is -4, so this is 2 raised to -4 is equal to, so applying the laws of exponent, so you have 1 over 2 raised to positive 4, and 2 raised to positive 4 is 16. So therefore, when your x is negative 4, the value of y is 1 over 16. Next, if we have negative 3, 2 raised to negative 3 is equal to 1 over 2 raised 2 cube, or 1 over 2 cube is 8, so 1 over 8, or 1/8. If your x is negative 2, so you have 2 raised to negative 2 is equal to 1 over 2 squared, which is also equal to 1/4. When your x is negative 1, so 1 raised to negative 1 is equal to 1 over 2 raised to 1, or 1/2. And when your x is 0, so 2 raised to 0 is, of course, that is 1. 2 raised to 1 is 2. 2 squared is 4. And 2 squared is 8. So this is the table of values for the values for the given values of x. Okay, so how about if we have the table of values for the second function, which is the logarithmic function. So if you can still remember, since these are inverse to each other, so what do you think are the values of x and y? What do you think is the domain and range of this? Okay, so in your previous lesson, you have learned that the range of the logarithmic function is just the domain of the exponential function, and therefore the domain of the logarithmic function is just the range of your exponential function. So in short, the values of x and y are just interchange, since these two functions are inverse to each other. Okay, so later we'll be sketching the graph of these two functions and see the relationship of the two functions. So let us sketch the graph of these two functions. We have y is equal to 2 raised to x, and we have y is equal to logarithm of x to the base 2. Okay, for the first function, our first point is negative 4, 1 over 16. Second point is negative 3, 1/8. Next, we have negative 2, 1/4. We have negative 1, 1/2. Next point is 0, 1. We have also 1, 2, 2, 4, and 3, 8. Okay, so we have these 7 points, and we will be connecting these points. So our function is y is equal to 2 raised to x. So this is the graph of our first function. Okay, so how about for our second function, y is equal to logarithm of x to the base 2. So we have our first point, 1 over 16, negative 4. So this is our first point. Second point is 1/8, negative 3. We have also 1/4, negative 2. 1/2, negative 1. 1, 0. And we have also 2, 1. 2, 1. Next, we have 4, 2. And we have 8, 3. 8, 3. So this is 8, 3. And we will be connecting these points. Okay, so our second function, this is the graph of our second function. Okay, so what have you observed about these two graphs? Remember that these two functions are inverse to each other. Okay, so we will be discussing that later. We will proceed to our next example. Let us proceed to example number 2. We'll be sketching the graph of these two logarithmic functions, and we will be discussing later the properties of these two logarithmic functions. Okay, so for the first function, we have y is equal to logarithm of x to the base 2. So the graph of this is, we have already sketched the graph of this function in example number 1. So this is the graph. And for the second logarithmic function, we have logarithm of x to the base 1/2. So this is the graph. Okay. And later we will be discussing the properties. Okay, so for the properties of these logarithmic functions, the first one is the domain is a set of all positive real numbers, or we can also write this as a set of x element of R such that x is greater than 0. So if you will be looking at the two graphs, so these graphs do not intersect your y-axis. So it means to say that the values of your x are always positive. These two will never intersect the y-axis. So there is no possibility that your x is 0 or negative numbers. So the values of your x are always positive real numbers. Okay. The second property, we have the range is a set of all real numbers. So looking at your graph, okay, so your graph, your second function is this, your first function is this, and this is your second function. So all the numbers on your y-axis can be reflected by these graphs. So it means to say the values of your y can be positive real numbers, negative numbers, and also you can have 0. Okay, so the range would be the set of all real numbers. For the third, it is a one-to-one function. It satisfies the horizontal line test. So in our previous lesson, we have discussed that a one-to-one function satisfies the horizontal line test. So what does it mean when we say horizontal line test? We can draw any horizontal line to the function and the intersection of this graph. And the intersection of this graph and the horizontal line is a point. Okay, so we can draw y is equal to 1, and the intersection of this line is this line and the graph is 2, 1, and then for the second function, this is the intersection of the line and the horizontal line in the graph. So any line you can have 4. You can have 4. So we have a single point of intersection, this one for the first function, and for the second function, this point. Okay, so these two functions are one-to-one functions. Okay, for the fourth property, we have the x-intercept is 1. Okay, so when we say x-intercept, it is a value of your x when y is 0. So both of your graphs intersect your x-axis at 1, 0. Okay, so the value of your x is 1 when your y is 0. That is what we call x-intercept. Okay, and there is no y-intercept, so we cannot have y-intercept because these two graphs do not intersect your y-axis. So therefore, there is no point of intersection of these two graphs and the y-axis. So therefore, there is no y-intercept. Okay, the fifth property, we have the vertical asymptote is x is equal to 0. So your x is equal to 0 is your y-axis. Okay, so it is a vertical line. Okay, so x is equal to 0. So this line. So both of your graphs approaches to x is equal to 0 but never intersect. Okay, so that is what we call vertical asymptote. But there is no horizontal asymptote. So there is no horizontal line being approached by these two graphs, and these two graphs will never intersect. So since our range is a set of all real numbers, so therefore there is no horizontal asymptote. Okay, so now let us discuss the relationship between the graphs of the logarithmic and exponential functions. So we have the first pair, y is equal to 2 raised to x, and the second function, we have y is equal to the logarithm of x to the base 2. So these two are inverse to each other. So let us see the graphs later. If what can we say about the relationship between these two graphs? And for the second pair of inverse function, we have y is equal to 1/2 raised to x, and y is equal to logarithm of x to the base 1/2. So let us start with the first pair. Y is equal to 2 raised to x. This is the graph. And the second function, which is its inverse, is logarithm of x to the base 2. So this is the graph. So what can you say about these two graphs? Okay, what do you think is the relationship between these two graphs? Okay, so remember, these two functions are inverse to each other. Okay, how about our second pair? So let us sketch the graph of the first function, y is equal to 1/2 raised to x. This is the graph. And for the second function, which is its inverse, is logarithm of x to the base 1/2. So what do you think is the relationship between these two graphs, the graph of an exponential function and the graph of a logarithmic function, which are inverse to each other? Okay, we have the first function, second function, and for our first pair, we have this and this one. So what do you think is the relationship? Okay, so for the relationship, we have Okay, so remember that logarithmic and exponential functions are inverse to each other, and their graphs are reflections of each other about the line y is equal to x. So again, these two graphs are reflection to each other about the line y is equal to x. Okay, y is equal to x. So what is that line? So this is the line y is equal to x. So they are just a reflection to each other about this line. Okay, how about the second pair? So these are inverse to each other. So again, they are just a reflection to each other about the line y is equal to x. Okay, so that's the relationship between the graphs of logarithmic and exponential functions, which are inverse to each other. So let us discuss example number 3. Sketch the graph of y is equal to 2 logarithm of x to the base 2, and we will determine the domain, the range, vertical and horizontal asymptotes, x-intercept or 0, and y-intercept. Okay, so let us first sketch the graph of the given function. So our function is y is equal to 2 logarithm of x to the base 2. So this is the graph. Okay, so let us identify the domain of this given function. So if you can observe, your graph can be found only on quadrants 1 and 4, and this graph will never intersect your y-axis. So it means to say that all the points on the graph, okay, the values of the x coordinate of these points on this graph are always positive. Okay, so your x are always positive. You cannot have the values of x equal to 0 or negative real numbers. So all the values of x are positive real numbers. Okay, so you have the domain is a set of x element of real numbers such that x is greater than 0 or positive real numbers. Okay, how about the range of this function? So remember, this graph is found on quadrants 1 and 4, and for the points on this graph, the values of your ordinate or y coordinates are or could be positive real numbers. It could be negative real numbers or 0. So all the points on this graph, their ordinates or y coordinates are real numbers. So therefore the range of this function are or could be y such that y is an element of real numbers. Okay, how about the vertical asymptotes? So can you find a vertical line being approached by this graph, but this graph will never intersect that vertical line? Okay, so let's have this part. So as you can see, we can see a vertical line being approached by this graph, but this graph will never intersect to that vertical line, and that is the y axis. And the equation of this line is what? The equation of that line is x is equal to 0. So we have x is equal to 0. So this is our vertical asymptote. Okay, how about the horizontal asymptote? Can you find a vertical line being, or a horizontal line being approached by this graph, but this graph will never intersect to that horizontal line? So you cannot find any. So therefore we have no horizontal asymptote. So how about the x-intercept? So again, for your x-intercept, it is the value of your x when y is 0, or in other words, this is the value of your x of the point of intersection of the graph and the x-axis. So this graph intersects your x-axis at point 0, 0, or point 1, 0. Okay, so again, it is the x intercept, or the 0 is the value of your x when y is 0. So therefore your x-intercept is 1. Okay, or algebraically you can solve for the x-intercept of this function. So how do we find for the x-intercept, or the 0 of this function? So it is very easy. So we let y is equal to 0 and solve for x, since the definition of your x-intercept is the value of your x when y is 0. So you have y is 0, so y is 0, and we'll be solving for the value of x. So we have 0 is equal to 2 logarithm of x to the base 2, and applying the loss of logarithm, your 2 is the exponent of x. So we can have 0 is equal to logarithm of x squared to the base 2. Okay, and applying, or if we will be converting this or expressing this into an exponential form, we have your base is 2, the answer is the exponent of 2, and the argument is the answer. So x squared is equal to 2 raised to 0, and 2 raised to 0 is equal to 1. Okay, so you have x squared is equal to 1, and to get the value of x, we will be getting the square root of both sides of the equation. So we have square root of x squared is equal to positive negative square root of 1. So we have x is equal to positive and negative 1. But remember in our previous discussion that your x here is always positive. It could never be negative. So therefore, we can never have negative 1. So the value of your x is only positive 1, and this x is our x-intercept, or 0. And for sure, your graph will be intersecting your x-axis at point 1, 0. Okay, so that is how we get the value of your x-intercept algebraically. Okay, how about the y-intercept? Okay, so since your graph does not intersect your y-axis, okay, it has no y-intercept. Okay, it has no y-intercept. So algebraically, let us see why we have no y-intercept. So we can also solve algebraically. Okay, so the definition of your y-intercept, it is the value of your y when your x is 0. So to solve for the y-intercept, we let x be equal to 0 and solve for y. So substituting the value of x, we have y is equal to 2 logarithm of 0 to the base 2. Okay, but remember that we have the value of your x equal to 0, so we cannot have 0 as the value of your x, because the value of your x will always be positive. So therefore your y-intercept, we have no y-intercept for this, and you would expect that the graph will never intersect the y-axis. Okay, that is for example number 3. We have determined the domain, the range, the vertical asymptote, the horizontal asymptote, the x-intercept or 0, and the y-intercept of the given logarithmic function. For example number 4, we will sketch the graph of y is equal to logarithm of x to the base 3 minus 1 and determine the domain, the range, the vertical and horizontal asymptotes, x-intercept or 0, and y-intercept. So first we will sketch the graph of the given logarithmic function. So this is the graph of y is equal to the logarithm of x to the base 3 minus 1. So what do you think is the domain? So take a look at this graph. The graph is found on quadrants 1 and 4. And what do you think are the x-coordinates of the points on this graph? Okay, do you think? So we have positive 9, 1. We can have 3, 0. Okay, so what do you think? Okay, so this graph will never intersect your y-axis, which simply means that all the x-coordinates or the points on this graph are always positive. Okay, so since your graph will never intersect your y-axis, your x could never be 0, or the values of your x could never be negative real numbers. So therefore the domain of this given function is, it is a set of x element of real numbers such that x is greater than 0, or your x are positive real numbers. Okay, how about the range? Okay, the range, so remember what would be your y coordinates if this graph is found on quadrant 1 and quadrant 4. What would be your our y coordinates of the points on the graph? Okay, so for example we have a point 9, positive 1. We can have 3, 0. We can have 1, negative 1. So you can have positive real numbers, you can have 0, you can have negative real numbers. So which simply means that your range would be a set of y such that y is an element of real numbers. So your y could be any real numbers. Okay, how about the vertical asymptote? So looking at the graph, can you find a vertical line being approached by this graph, but this graph will never intersect to that vertical line. Okay, for sure, and that line is x is equal to 0, or the y-axis itself, and the equation of that line is x is equal to 0. So therefore, the x is equal to 0 is our vertical asymptote. And how about, can you find a horizontal line being approached by this graph, but this graph will never intersect this horizontal line? Okay, there is no of that horizontal line, and therefore for this function we have no horizontal asymptote. And we will proceed to the x-intercept, or 0. Okay, can you find the intersection of the graph and the x-axis? Okay, so this point, and the coordinates of this point are, we have 3, 0. Okay, so again, the x-intercept, or the 0, is the value of your x when y is 0, and therefore your x-intercept is 3. Okay, so algebraically we can solve for the value of your x-intercept, or 0. So to find for the x-intercept, we let y be equal to 0 and solve for x. So substituting to the original function, your y is 0, so it's equal to logarithm of x to the base 3 minus 1. Okay, applying the addition property of equality, your negative 1 becomes positive 1, and then you have logarithm of x to the base 3. If we will be expressing this as in exponential form, so your base is 3, the answer is the exponent, in your argument we have x, and 3 raised to 1 is 3, so therefore the value of your x is 3, which is also your x-intercept. So your x is 3 when your y is 0, so that is what we call the x-intercept. Okay, how about your y-intercept? So of course, since the graph does not intersect your y-axis, therefore there is no y-intercept. Okay, and if we will be showing that algebraically, so we let x be equal to 0 and solve for y. So substituting the values of x, which is 0, so you have y is equal to logarithm of 0 to the base 3 minus 1. So this is already undefined because the value of your x must be always it is always positive, so we cannot have 0 or negative real number. So that is why your given function has no y-intercept. Okay, so again, for the domain, we have the set of x element of real number such that x is greater than 0 or positive. Your domain is a set of y such that y is an element of real numbers. Your x is equal to 0. We have no horizontal asymptote. Your x-intercept, or 0, is 3, and we have no y-intercept for the given logarithmic function. So let us discuss the last example, which is example number 5. Sketch the graph of y is equal to logarithm of x plus 2 to the base 0.25, and determine the domain, the range, the vertical and horizontal asymptotes, x-intercept, or 0, and y-intercept. And Let us start by sketching the graph of this function. So this is the graph of the given function. So what do you think is the domain? Okay, so as you can see, the graph, this is the graph of the given function, and the graph will never intersect to the vertical line x is equal to -2. So it means to say that the values of your x, okay, remember this, the graph is found here. It means to say that the values of your x is a set of x element of real numbers such that x is greater than -2. Okay, so the values of your x is always greater than -2. It could never be equal to 2 because this graph will never intersect the line x is equal to -2, and it could never be, or the values of x could never be less than -2. Okay, so the domain of our given function is a set of x element of real numbers such that x is greater than -2. How about its range? Still, the range is a set of real numbers. So your value of y can be positive, can be negative. So this part, the value of your y can be negative, and your value of y can be 0. So therefore, your range would be a set of y such that y is an element of real numbers. Okay, how about the vertical asymptote? So earlier we had sketched the graph of the line x is equal to -2, and this is a vertical line being approached by the graph, but this graph will never intersect. So therefore, the vertical asymptote is the line x is equal to -2. And again, we have no horizontal asymptote, meaning there is no horizontal asymptote because there is no horizontal line being approached by the graph, and this graph will never intersect this horizontal line. So therefore, we have none. Okay, and since our range is an element of real numbers, therefore we have no horizontal asymptote. How about the x-intercept or 0? So the graph intersect your x-axis at point, this is the point, we have -1, 0. Okay, and therefore your x-intercept is -1. So algebraically, let us solve our x-intercept. Okay, so let y be equal to 0 and solve for x. So substitute 0 is equal to the logarithm of x plus 2 to the base 0.25. Okay, expressing this as an to the exponential form, we have we will express this first as a fraction. So this is 1/4. So this is the base 1/4. 0 is the exponent, and the argument would be the answer of your exponential form. We have x plus 2, and then 1/4 raised to 0 is equal to 1, and then we have is equal to x plus 2. Applying the properties of equality, we have 1 minus 2 is -1. That is the value of your x, and therefore we have the x-intercept -1. So this is the value of your x when your y is 0, and that is -1. Okay, so how about the y-intercept? Okay, so looking at your graph, where does the graph intersect your y-axis? So this point. Okay, so but looking at the intersection, we cannot exactly determine the coordinates of this point, but we all know that the value of your x is 0. Okay, 0 what? So we cannot estimate the value of your y coordinate unless we will be solving the value of y algebraically. Okay, so by just looking at the graph, we cannot estimate the value of your y-intercept unless we will solve algebraically. So to do that, let us solve for the value of y algebraically. Okay, so we have y-intercept. We let x be equal to 0 and solve for y. So substitute, your x is 0, and then 0 plus 2 is 2. So we have now this logarithmic function, and we will express 0.25 as fraction, so you have 1/4. So logarithm of 2 to the base 1/4, and then we will express 1/4 so that we can have a negative exponent. So your 1/4 can be expressed as 4 raised to negative 1, applying the loss of exponents. Okay, and then we will express 4 raised to negative 1 so that we can have 2 as the base. So your 4 raised to negative 1 can be expressed as 2 raised to negative 2. Okay, so that we can have the same base. We have 2 and 2, the base of your logarithm and the base of your argument, and we will be expressing this as or we will be expressing this in exponential form, and the exponential form of that is, so this is the base 2 raised to negative 2, the exponent is y, and the answer is 2. Okay, this is the exponential form of this logarithmic form. Okay, so from here we'll be applying the loss of exponent. Okay, power to power, so we have negative 2 times y is negative 2y, so we have 2 raised to negative 2y is equal to 2. Okay, so since we have the same base, we can equate the exponent. So the exponent of 2 here is 1, so taking the exponents, we have negative 2y is equal to the exponent of 2, which is 1, so we have 1. So negative 2y is equal to 1, and solving for the value of y, we will be dividing both sides of the equation by negative 2. So you have the value of y is equal to negative 1/2. So it means to say that the y-intercept is negative 1/2. So going back to our graph, the graph intersects your y-axis at point 0, negative 1/2. Okay, so this is the intersection of the graph and the y-axis, such that your y-intercept is negative 1/2 or negative 0.5. Okay, again, for example number 5, we have the domain x element of real number such that x is greater than negative 2. The range is y such that y is an element of real numbers. Your vertical asymptote is x is equal to negative 2, so this is the line, the vertical line. We have no horizontal asymptote. Our x-intercept or 0 is negative 1, and your y-intercept is negative 1/2 or negative 0.5. Okay, that is for example number 5. Okay, so for this video tutorial, we have discussed how to um, sketch the graph of the logarithmic functions, and we have also discussed um, how to identify the domain, the range, the vertical asymptote, the horizontal asymptote. We have also discussed how to get the x-intercept and the y-intercept. Okay, so I hope you have learned something out of this video tutorial. Thank you very much.